Algebra 2 notes. This is 1.5 part 1, and this is solving inequalities. You're going to use these notes for IHL C.2 and C.4. So today's learning targets are today you'll be able to solve and graph inequalities. So let's go ahead and look at the key concept. So when you solve and graph an inequality, what happens is that you're going to read it and then you're going to graph it. So we need to talk about what's open and closed. So for the first inequality, I have x is greater than 4. And I know that this is going to be an open inequality, and I'm going to shade to the right of the number 4. The next inequality is x is greater than or equal to 4. So this is what we call a closed inequality, and we shade to the right of the 4. And then next, we have x is less than 4. So this is also an open inequality, and we shade to the left of the 4 because it's negative. And then x is greater than 4 means that this is, or greater than or equal to 4, means that this is going to be a closed inequality. And we use the open symbol and then a closed period for the close. So another thing I want to go over is, again, the direction that we shade. When it's greater than, you shade to the right, and it's open. When it's when it's greater than or equal, you also shade to the right, but it's a solid dot. And then when it's less than, it's open and you shade to the left because that's negative. And then when it's less than or equal to, it's a solid dot and you also shade to the left because it's negative. Set of examples, we're going to write an inequality from a sentence. So what inequality represents the sentence 5 fewer than a number is at least 12? So the first thing we need to know is that when we have the word fewer than, we're going to reverse the 5 in the variable. So we're going to say that x is minus 5. And then when you have at least 12, that means that it's going to be greater than or equal to 12. Okay, for the next example, the your turn, the inequality represents the quotient of a number and is no more than the quotient of a number and 3 and is no more than 15. So the quotient needs to divide. So I'm going to use the variable x, and I'm going to use, for the no more statement, I'm going to use less than or equal to 15. So it's going to be x divided by 3 is less than or equal to 15. So now we're going to have a discussion about the big idea. So the big idea basically is solving inequalities. When you solve inequalities, there's a very specific rule that you must have. And that rule is when you multiply or divide by a negative, you must flip the inequality arrow. So here's an example. Suppose I have negative 5x is less than or equal to 25. I want to solve for x. So to solve for x, I'm going to divide both sides by negative 5. So I can get x on its own. So when I divide both sides by negative 5, I switch or flip the direction of the inequality. If you notice, before it was pointing to the left and now it's pointing to the right. So that means that x is going to be greater than or equal to negative 5. Again, I want to just make this very clear. The inequality right here has switched directions, okay? The directions are different now. So instead of going to the left, it now goes to the right. Okay, so now we're looking at example 2. So example 2 says that it's going to be negative 3 times 2x minus 5 minus 1 is greater than or equal to 4. So in this case, we want to just write that in. We're going to distribute, and then, which means to multiply by the negative. So when I get that, here's what I get. I get negative 6x plus 15 plus 1 is greater than or equal to 4. And then I collect like terms. So I have negative 6x plus 16 is greater than or equal to 4. So I'm going to subtract 16 from both sides because I want to get x on its own. And then I'm going to have negative 6x is greater than or equal to negative 12. So right here, I'm going to divide by negative 6. So when I divide by negative 6, I'm going to change the direction of my inequality. So negative 6x divided by 6 is less than or equal to negative 12 divided by 6, which is x is less than or equal to negative 2. So when I graph that, I'm going to graph everything to the left of 2. All right, here is the new problem. So I have negative 2 times x plus 9 plus 5 is less than or equal to 3. So I'm going to distribute the negative 2 into the first set of parentheses. So I have negative 2 times x and negative 2 times 9 plus 5 is less than or equal to 3. So I have negative 2x minus 18 plus 5 is less than or equal to 3. I collect like terms. Negative 2x minus 13 is less than or equal to 3. I'm going to add 3 to both sides. I bring down that negative 2. So I have negative 2x is less than or equal to 16. So I'm going to divide both sides by negative 2. And then that changes the direction of my inequality. So I say x is greater than or equal to negative 5. And when I graph that, it's going to be closed and everything to the right. I'm sorry, x is greater than or equal to negative 8. So when I graph that, it's negative 8 and everything to the right is shaded. So because we want everything greater than negative 8. How to use inequality. This is just like a normal word problem or systems of equations. So suppose I have a movie rental company that offers 2 subscription plans. How many movies must you rent in a month for the first plan to cost less than the second plan? Plan 1 is $36 a month with unlimited rentals, and Plan 2 is $15 a month plus $1.50 per rental. So let's go ahead and set this up. So I know that x is going to be less than, because it says cause less, $15 plus $1.50, and then x is the number of rentals. So I'm going to solve for x here. So to do that, I'm going to subtract 15 from both sides. I get 21 is less than 1.5x. Then I'm going to divide both sides by 1.5 to solve for x. So 21 divided by 1.5. And then 1.5x divided by 1.5. I get x is less than 14. So I know that that means that I must rent more than 14 movies for Plan B to cost less than Plan 2. Problem. The digital music service offers 2 subscription plans, and how many songs must you download for the second plan to cost less than the first plan? So we have to set up the first plan and set it up less than the second plan. So the first plan is $9 fee plus $1 per download, and the second plan is $25 fee for 50 cents per download. So the first one is going to be 9 plus x, and then the second one is going to be 25 plus 0.5x. So I want to show that Plan 2 is less than Plan 1, so that's why I put Plan 2 before Plan 1. So I get 25 plus 0.5x is less than 9 plus x. And then I subtract 9 from both sides. So I get 16 plus 0.5x is less than x. I subtract 0.5x from both sides. And then I get 16 is less than negative 0.5x plus x. So I get 16 is less than 0.5x. I divide both sides by 0.5 so I can get x on its own. So 16 divided by 0.5 is less than 0.5x divided by x. So x is going to be, so 32 is going to be less than x, which means that you need to buy more than 32 songs, because I can always write this as x is greater than 32. So you need to know that those two are the same. Okay, let me highlight it. So this is the same as that. Example 4, where inequalities with no solution and all real numbers are solutions. And we want to ask ourselves, is the inequality always, sometimes, or never true? So here are some scenarios where they're always true. So this is the equation. We have 5 times 2x minus 3, in parentheses, minus 7x, is less than or equal to 3x plus 8. I rewrote it because that was hard to read. So then it's distribute the 5, so I get 10x minus 15 minus 7x is less than or equal to 3x plus 8. I'm going to collect like terms, so 10x minus 7x gives me 3x minus 15. It's less than or equal to 3x plus 8. I'm going to add 15 to both sides. I get 3x is less than or equal to 3x plus 23. And then I subtract 3x from both sides, so then I get 0 is less than or equal to 23. And this is going to be a situation where the inequality is always true because the 0 is less than 23. So here is an example where the inequality is sometimes true. So I have 9x plus 2x times x, or 2 plus x, is less than 5 plus 9x. I distribute the 2 into the parentheses, so I have 9x plus 4 plus 2x is less than 5x plus 9. I collect like terms, so I'm going to have 11x plus 4 less than 5 plus 9x. I'm going to subtract 9x from both sides. So I say 2x plus 4 is less than 5. I'm going to solve for x, so I'm going to subtract 4 from both sides. So I get 2x is less than 1. And I divide both sides by 2. So 2x divided by 2 less than 1 divided by 2. So x is going to equal, or x is going to be less than 0.5. So this is a situation where it's all real numbers less than negative 0.5. Okay, so let's look at a never true. So a never true for this scenario is going to be negative 2x times 3x plus 1 is greater than negative 6x plus 7. I'm going to distribute the negative 2 to both sides. I'm sorry, to both items in the parentheses. So I get negative 6x minus 2 is less than negative 6x plus 7. I add 6x to both sides, so I have negative 2 is greater than negative 7, and this is false because negative 2 is actually smaller than negative 7. So let's talk about this scenario a little bit. It says no solution and real numbers as solutions. So in a scenario where I had negative 15 is less than or equal to 8, we have real number solutions. So let's talk about this. We're going to have real number solutions, and then the variables disappear, and we know it's a true statement. And the reason why we know it's true is because when we graph this, 8 is right here, 0 is right here, and way over here is negative 15. So we can say that definitely negative 15 is less than or equal to 8. Right? And 8 is all the way over here. So it's definitely less than because it's everything to the left of negative 8. Okay, so let's look at this scenario with our variables. So this is sometimes. So sometimes you find a solution and the variables do not disappear. So what this means is that when I have x is less than 1/2, I'm going to say that 1/2 is right here on the number line, and then I have 0. So we want to say that all x's less than 1/2. And that's going to be x is less than 1/2. And when I shade that in, here's what I get. I get open, and I get everything down over here to the left of 1/2 because it's less than, right? And then let's look at a solution where it's never true. So this is going to be for negative 2 is greater than 7. And we want to say this is never true or a false statement. And it's no solution. And then the variables disappear. So no solution, variables disappear. And then when we're drawing this out on a number line, we say 7 is over here, 0 is here, -2 is here. And so we know just by reading it that -2 is less than 7. But if you look at this symbol right here, it's actually saying greater than. So that's why it is a false statement, right? Because this is what's true. So this would make it true. And this right here is false. So that's why we say it's never or no solution. We need to determine is the equation always, sometimes, or never true. We have our examples on top. So let's go ahead and look at A. So for A, I'm going to rewrite it. And I have 4 times 2x minus 3 is less than 8 times x plus 1. So I'm going to distribute the 4 into the first set and then the 8 into the second set. So I'm going to get 8x minus 12 is less than 8x plus 8. I'm going to subtract x from both sides. So those 8 x's go away, or I'm going to subtract 8x. So I get -12 is less than -8. And this is true. It's always true. So let's draw the number line just in case. So in the middle we have 0, we have 8 here, and then further down I have -12. So I'm asking you, is -12 is less than 8? So when I write it out, we say yes. So again, that's what makes it always true, because this is true, all right? And it's true on the number line. Let's look at our second equation. So in this case, for B, we have -6 times 2x minus 10 plus 12x is greater than or equal to 180. So it's -6 is going to get distributed into the parentheses. So I get -12x plus 60 plus 12x is greater than or equal to 180. I collect like terms, so I get 60 is greater than or equal to 180. And unfortunately, this is false, and this is never true. So let's talk about why it's false. So the reason why it's false is because when I have a number line, if I look at 0, I look at 60, 120, 160, and then somewhere right here is 180, right? So if I look at 60 and 180, I have to say 60 is less than 180. And then if I write this out, 60 is greater than or equal to 180. And we both know that that's false, right? 60 is not. So this right here is true, and this right here is false. So again, it's false. Oops. We want to say it's false. So it's never true. And then when we make it true, would say 60 is less than 180. Would make it true. Okay? So basically what I want you to do is I want you to pose a question about the lesson. And I want you to answer the question in the summary. That's what you do in the summary. A lot of you are turning in notes without the summary, and that's not what we want. So you're going to ask a question in the lesson, and you're going to answer the question in the summary.